Sometimes we will encounter a word problem that deals with variation. Variation is when and how one quantity varies with respect to another quantity. There's going to be 4 types of variation we're going to see in this class. We're going to see direct variation, we're going to see inverse variation, we'll see joint variation, and we'll also see a combination of these 3. So we'll call it a combination variation. What I'm going to do is I'm going to introduce you to each one of these, and we're going to do some easy problems involving variation, and then we're going to move on to word problems. We're going to start with direct variation. So let x and y be 2 quantities. If y varies directly, with x, then there exists a number k not equal to 0, so some number other than 0, such that y is equal to k times x. When we want to work with direct variation, we'll see it written in the problem. You'll have some kind of word problem that says y varies directly with x. And of course you could use different letters as well. So let's look at a few examples so we can get familiar with this. So let's write a general formula to describe each variation. So here's the first one. We just talked about this. When y varies directly with x, that means y is equal to some number k times x. And this number k is fixed. Let's try this one. V varies directly with t. So that means v is equal to some number k times t. How about r varies directly with the square of x? So here's varies directly. What we're doing is we're writing an equation. So we're trying to take these words and put it in the form of math. So r, so when we see varies directly, that means k times what? The square of x. So this is x squared. So r varies directly with the square of x. This one says y varies directly with the square root of x. Find k if y is 10 when x is 4. Okay, let's start with this first sentence. Y varies directly, so y is equal to k times the square root of x, so that's square root of x, just like that. So here we come up with an equation. Now we want to actually find this number k. And how we're going to do it is we're going to be given a y and an x. So when y is 10, so we're going to put 10 here, we have that x is 4. So we're just plugging in those 2 numbers in for x and y. So the square root of 4 is 2. And then we solve for k. K is equal to 10 over 2, which is 5. We can also rewrite this equation. So the y and the x vary. So when x goes up, then y is going to go up. When you have a direct relationship like this, x goes up, y goes up. When x goes down, y goes down. So we have that y is equal to 5 times the square root of x. the k doesn't change. The k is a constant number. So we can rewrite this relationship by plugging in this number 5. Now we only can find k if we know the variables, some numbers for the variables. Let's try this one. Z varies directly with the sum of x and y. Okay, so Z varies directly means is equal to k times something, and what you're going to multiply by is the sum of x and y. The sum means we add them, x plus y. Now let's talk about inverse variation. So again, we're going to let x and y be two quantities. So just some amounts. If y varies inversely, with x, then y is equal to k divided by x. So varying inversely means when x goes up, y is going to go down. Or when x goes down, y goes up. So it's like an inverse relationship. When we vary directly, if x goes up, y goes up. If x goes down, y goes down. But inversely means we have a different order here. X goes up, y goes down. So opposite relationship. Okay. Also, there exists a non-zero number k. I think that's how I wrote it last time, so let me write that as well. So then there exists a k not equal to 0 such that, I just kind of want to follow what I wrote before, but this is the main part. Whenever you see varies inversely, this is the equation you're going to be using. Y is equal to k over whatever you're varying inversely with respect to. Now, like some of the problems we just saw, it might say something like v varies inversely with the square of t. Then you would have like v is equal to k divided by t squared. So you can replace these letters, but this part here always implies that we have k divided by something. So let's look at some problems. Let's write a general formula to describe each variation. Okay, y varies inversely with x, so that means y is equal to k over x. V varies inversely with the cube of x. Then we want to find k if v is equal to 6 when x is 2. And then we have one more thing we want to do, which is what is v when x is 3. So let's start with this first part. Let's come up with an equation. So v varies inversely, so that means v is equal to k over, when we see varies inversely, equals k divided by. Then we just have to write this in terms of symbols. The cube of x means x raised to the third. So now we have an equation. We want to find k if v is equal to 6 when x is 2. So just plug these two pieces into these places right here. So 6 is equal to k over 2 cubed. Let's simplify that. That's 6 is equal to k over, 2 cubed is 8. Now 6 times 8, that's 48. So that is equal to k. So we found k. Now we can rewrite this equation. This equation is now v is equal to 48 over x cubed. Now remember, k is a constant, it doesn't change. But x and v change. And here I have that what is v when x is 3? Now I'm going to plug in 3 into this equation here. So v is equal to 48 over 3 cubed. which is equal to 48 over 27. Let's see if we can figure that out. 48 over 27 is about 1.77. You can leave it like this, but I'm also going to say this is about 1.78. And notice what happened. When x was 2, v was 6. When we increased x, what happened to v? It went down. It went down to 1.78. So this is the inverse relationship I was talking about. And how it's going down depends on this number k. Let's come up with an equation for this one. Y varies inversely with the absolute value of x. So that's just y is equal to k over the absolute value of x. And sometimes you might see that written out. Absolute value of x would just be this. Let's move on to joint variation. So joint variation is variation that involves the product of two or more variables. In fact, I'm going to write right above this variation, I'm going to add a word. I'm going to say is direct variation. So we know what direct variation is. Usually we have something like y is equal to k times x. But joint variation means I'm going to add another letter here. So something like y is equal to k times x times r. So the product of two or more variables. So it's exactly what you expect with direct variation. You just have more stuff on this side here. So let's look at a couple of examples. Let's write a general formula for this type of variation. So y varies jointly with x and y. So this is going to be y varies jointly is equal to k times. And jointly means product. So we're just going to take the product of x and z. So x times z. Another way to read this, or you can even rewrite it as it varies directly with the product of x and z. So when you see varies jointly, you want to think varies directly with the product. Okay, they don't say product here. You see y varies jointly with x and y. Product is what this jointly means. Let's try this one. V varies jointly with the square of c and p. Okay. V varies jointly means is equal to k times, and then we need to do a product. The product of the square of c and p. So this part is a little confusing. What we're squaring is just c. So the c squared and p. If I wanted to square p as well, I would say with the square of c and the square of p. Or I would say with c and p squared. Okay, but the fact that I put the square in front of just the c, that means I'm going to multiply c squared with p. Now we have a little bit of a word problem here. T varies jointly with the cube root of x and the square of d. If t is 18 when x is 8 and d is 3, find t when x is 2 and d is 4. Okay, so let's see if we can do that. We're going to start with the first sentence here. T varies jointly, so t is equal to k times, and it's going to be times a product. The product of the cube root of x and the square of d. So the cube root of x looks like this, and the square of d looks like that. So we've taken care of this first sentence. Now remember, k is a constant. If t is 18, so 18, when x is 8, so the cubic root of 8, and d is 3 times 3 squared, we want to find t for some other values of x and d. So what we're doing here is when they give you this first piece, you need to find k. Because remember, x, d, and t vary. And when x and d change, t is going to change. But k stays the same. So we have a relationship between x, d, and t, this particular relationship. But just by looking at it, I can't tell what t is going to be if I change x to 2 and d to 4. How I'm going to do that is I'm going to find k. So I'm going to plug this information in, this first part of the sentence before the comma, and I'm going to use it to find k. So we have 18 is equal to k. The cubic root of 8 is 2, and 3 squared is 9. So I get 18 is equal to k times 18. So divide both sides by 18, I get k is 1. So now I can rewrite this equation as t is equal to 1 times the cubic root of x times d squared. And I don't even really need to put that 1 there, but I can put it, I mean, it's not going to change anything. So it's really, we're just ignoring it. Now all we have to do to figure out this part, to find t, is we plug it into this equation. So t is equal to the cubic root of 2 times 4 squared. So t is going to be the cubic root of 2 times 16, and I'm going to leave this as t is equal to 16 cubic root of 2. You can put it in the calculator if you want to. This is the exact answer. Now let's talk about combined variation. So combined variation, this is combinations of direct or joint variation and inverse variation. We're going to see some examples, and we're going to have in the sentence, oh, this varies directly with x and inversely with z, something like that. And we're going to have multiplication and division. So let's write a general formula to describe each variation. Let's start with this one. I'm going to go slowly. Of course, you can always speed up, you can move on to another problem, you can pause the video, put your answer for the problem, and then if you need to listen to how I describe it, then you can listen. But do what's best for you. Just make sure you do plenty of examples. So here I have that z varies directly with x and inversely with y. Z varies directly means z is equal to k times, it varies directly with x, so it's k times x. So that's half the problem. Now, it also varies inversely with y. That means I just divide by y. So you can see z is equal to k over y because it varies inversely with y, and at the same time, it varies directly with x, so we have k times x. So you're not going to put two k's here, you're only going to use one k. The next one says, suppose z varies directly with the sum of the cube of x and the square of y, and it varies inversely with r. Find k if z is 1, when x is 2, y is 3, and r is 1. A lot of stuff going on here, but let's just work through it slowly. So z varies directly. That means z is equal to k times. It varies directly with the sum. Well, what are we summing? We're summing the cube of x, which is x to the third, and the square of y. so y squared. So we're going to sum these two. So it's x cubed plus y squared. Ask yourself, does this make sense with the sentence? So z varies directly, k times the sum, so we're adding two things, x cubed plus y squared, okay? And it varies inversely with r. So then we need to put a division sign here and put r on the bottom. Let's find k when z is 1. So let's put this information. Z is 1 is equal to k times x is 2, so 2 cubed plus y is 3, 3 squared, divided by r is 1. Well, that's a really nice number to divide by because we're not really going to have a fraction, are we? We're going to have that 1 is equal to k times 2 cubed is 8, 3 squared is 9. So we get 1 is equal to k times, this is going to be 17. And then we just divide by 17. So we get 1 over 17 is equal to k. And then, especially on your homework, it might ask you to write the new equation involving this number k that you found. So all you're going to do is you're going to erase this k here. And you're going to put what k is, which is 1 over 17, like that. But also, because this is a fraction, I could just stick this 17 in the bottom, because this is 1 over 17 right here. Now, if I didn't have the number 1 for r, I would have to get rid of this fraction here, I'd have to multiply both sides by whatever number that was. So if this was a number 8, like r was 8, then I'd have to multiply this by 8, and I'd get 8 is equal to k times this. So it would be 8 over 17. Let's try another little word problem. Suppose the cube of z, let me erase this, I don't like that. Suppose z move this over. Okay, now let's try this one. Suppose z varies jointly with x and y, and inversely with the square of t. So we need to come up with an equation for this. And then if z is 4 when x is 1, y is 3, and t is 2, we want to find x when z is 7, y is 3, and t is 5. Okay, maybe pause the video, jot this down, and maybe even try to see if you can figure this one out on your own. Okay, I'm going to write the equation over here. So z varies jointly, that means a product of x and y, so x times y, and inversely, which means divide, by the square of t, so t squared. Here we have our equation. Now we're going to use this equation. They're giving us z, x, y, and t, so z, x, y, and t. The only thing they don't give us is k, which if we know all the other variables, we can solve for k. Then we want to find x, so once we know k, remember k is fixed, it doesn't change, x, y, t, and z change, but not k. So if we know z is 7, so we know z, we know y, and t, well, we'll also know k from the first part, then we can solve for x. So let's plug all this in. So z is 4 is equal to k times x times y over t squared. Tells us that 4 is equal to k times 3 over 4, which means 16 is 3k, or k is equal to 3 over 16. So we found k. That's only part of the problem. Now we want to find x. So to find x, we're going to use the equation. I'm going to rewrite it now. Z is equal to k, which is 3 over 16, times x times y over t squared. That's what z is equal to. And this 16, like I mentioned before, I can actually put it in the denominator. So it's 3xy over 16t squared. So this is the equation if we get rid of the k. And now we're going to find x. We're going to plug in z, y, and t. So when z is 7, we get 3 times x times y, which is 3, divided by 16, right here, times 5 squared. Let's clean this up a little bit. This is 7 is equal to 9x. 3 and 3 make 9. Then 16 times 25. I think I'm going to need a calculator for that. So 16 times 25 is 400. So we have that 7 is 9x over 400. Now solve for x. Well, we can multiply by the reciprocal here. So we get 7 times 400 over 9 is equal to x. So multiply that by 7. And let's see, that's not divisible by 9, is it? No. So I'm going to leave it as a fraction. So this is 2800 divided by 9. So we were able to find a variable other than what was on the outside of the equation just by plugging in everything and solving for x.